Welcome back to our Chapter 8 video series. This video we are going to talk about the resonance in Lewis structures. What is the resonance theory? Well, basically it is how we question where to place the double bond in some of our structures. Here you'll notice ozone has 3 oxygens. It has a total of 18 electrons. So with the central oxygen in ozone, it does not have an octet. Therefore, a double bond has to form. Well, if we number our oxygen atoms, number this 1, 2, 3, or 1, 2, 3, you'll notice that the double bond can either go between 2 and 3 or 1 and 2. So the question becomes, how do we know which bond will be the double bond? The same thing occurs with the nitrate ion. Here with nitrate, it has 3 oxygens, 1, 2, 3. Nitrogen here does not have an octet, so it can have a double bond here, here, or here. So where do we put the double bond? Carbonate falls into the same pattern. 3 oxygens can have a double bond between carbon and oxygen here, between carbon and oxygen here, or carbon and oxygen here. So where does the double bond go? In all 3 cases, when forming a double bond from a terminal oxygen or an outside oxygen, one has a choice of moving electrons from several different oxygens to make the central atom's octet. Examination of experimental evidence through X-ray sheds an interesting light on this topic. When 2 atoms are bonded together, the distance between their nuclei, or their bond length, depends on whether the bonds between the 2 are single, double, or triple. We want to take a look at a few of these so that you can see the pattern that happens when you have single, double, and triple bonds. Here with carbon, you'll notice that as you increase the number of bonds between 2 elements, you are decreasing the size of the bond. So the triple bond here is the shortest. Single bond is the longest. If you look at all of these, between carbon and nitrogen, decreases. Between carbon and oxygen, decreases. You'll notice that the triple bonds are shorter than double, and you can also notice that the doubles are shorter than single. The 3 bonds also have different strengths. Triple bonds are our strongest, so if you have the shorter the bond, the stronger it is. So even though it's shortest, it's strongest. And the longest bond will be the weakest. Very important for you to keep in mind the relationship between the length of the bond and its strength. X-ray evidence of bond lengths in ozone, nitrate, and carbonate ions should therefore prove interesting. If we take a look at the ozone molecule, if we predicted, based on what we just looked at, the single bond between the 2 oxygens, right here, should be the longest, whereas the bond between the 2 oxygens with the double bond should be shorter. Instead, when they used X-ray to examine the oxygen molecule, it was actually showed that each bond was identical. Each bond had a length of about 127.8 picometers. This is close to about an average of 1.5 bonds to each oxygen. Linus Pauling proposed the theory of resonance to describe the situation. In his theory, he stated that when 2 or more equivalent Lewis structures can be drawn, differing only in the position of electron pairs, then none of the Lewis structures are correct. Instead, the real structure is a hybrid of all structures drawn. The Lewis structures drawn are called contributing or resonant structures, needed to describe the makeup of the hybrid, which resembles all but is none of the above. A special double-headed arrow is drawn between the contributing structures to indicate their hypothetical nature. So we're going to use a double-headed arrow here to show that some of the structure is based on this Lewis structure and some of the structure is based on this structure. The hybrid structure with 2 equivalent bonds to the central atom are said to have a bond order of 1.5. or an average of 1.5 bonds between each oxygen. To find the bond order, what you take is the number of bonds divided by the number of atoms bonded to the central atom. Here is what the proposed hybrid structure of ozone looks like. And this would be basically an overlapping. If we would take both Lewis structures that we saw on the previous slide and overlap them, this would be what the hybrid structure looks like. The bond order describes the number of bonds between two atoms in a molecule. Normally, the bond number is 1 for single bond, or 2 for double, or 3 for triple. When hybrid structures and residence situations exist, one must average the number of bonds between all atoms affected, and fractional values arise. In the case of the nitrate and carbonate ions, the number of bonds to the central atom is averaged out over 3 atoms, and 4 bonds divided by 3 atoms equals a 1.33 bond order. In both cases, X-ray data confirm this theory. So here you'll recognize the carbonate ion from earlier. Each of these, and we should have a double-headed arrow here as well. Each of these is a Lewis structure that you could draw, but because the double bond can basically migrate between the carbon and any of the oxygens, you get this hybrid structure. And based on this hybrid structure, the bond order is a 1.33 bond order between carbon and oxygen. Nitrate's the same thing. You'll notice the 3 different structures. The hybrid is here, and it will also have a 1.33 bond order. That is the end of our resonance structure lecture. The last lecture we're going to talk about is bond enthalpy.